and welcome to this podcast for the University of Alabama at Birmingham Research Center of Excellence in Arsenicals. My name is Mina Nabavi, and I am a program manager in the UAB School of Public Health. Today we are joined by Dr. Anupam Agarwal, Director of the Division of Nephrology and Executive Vice Dean for the School of Medicine at UAB. Dr. Agarwal also serves as the Program Director of the NIH and the National Institute of Diabetes and Digestive and Kidney Diseases funded O'Brien Core Center for Acute Kidney Injury Research. Dr. Agarwal is the lead for Research Project 3 as part of the UAB Research Center of Excellence in Arsenicals. The project titled Intercepting Renal Damage Following Skin Exposure to Arsenicals is based on findings that cutaneous exposure to lewisite not only damages skin, but is also rapidly absorbed and exerts toxic effects in the kidney, leading to both acute and delayed kidney damage. He is here to talk with me about the effects of arsenicals on kidneys and his work with the center. So thank you so much for being here today.
Thank you, Mina. Thank you for inviting me to do this.
Absolutely. So for our first-time listeners, can you provide a brief overview of the Research Center of Excellence in Arsenicals, the mission of the center?
So the center that is led by Dr. Athar in dermatology is to meet the requirements of the NIH CounterACT program to develop novel antidotes to chemicals or other potential toxic agents that people can be subjected to or be exposed to through bioterrorism or through a disaster or a spill from an accident and so on. So our center is focused on a chemical that was used in World War I and II very extensively called lewisite, which is an arsenical. People are exposed to lewisite. It can cause extensive skin damage, not only in blistering, inflammation, but can also lead to organ injury in the lung, in the kidney, in the liver. And that's really the focus of this programmatic initiative through the NIH, focusing on multi-organ injury through exposure to arsenicals and how we can develop timely antidotes for counteracting this damage.
Gotcha. So can you talk about how arsenicals, or specifically lewisite, impact the kidneys?
Lewisite or other arsenicals, they get absorbed from the skin, and we have measured the blood levels, and very quickly the blood levels go up, quite high. And these agents are excreted by the kidney. So unfortunately, as they pass through the kidney, these arsenicals can damage the kidney through what are called free radical mediated mechanisms. Okay. And they can damage the proximal tubule, which is the main component of the kidney, the filtering apparatus as well, the blood vessels in the kidney, and that leads to kidney failure very quickly. But we've also found that just a single exposure to an arsenical like lewisite can lead to long-term damage, at least in animal models. Wow. 6 months later, these animals have decreased kidney function just from one single exposure. It's a huge impact to the body, being exposed to this accidentally or by a terrorist who's trying to use this chemical
against a certain group of people. So how does the route of exposure through the skin, like you just spoke about, or through drinking water, ingestion, impact the kidneys? Is it different or is it the same?
It has to get absorbed into the circulation. The kidney gets about 180 liters of blood a day. Wow. So anything that gets absorbed, if you eat it or drink it, it'll get absorbed through your GI system, and then it goes into the blood, and then that's where it gets exposed to the kidney. And the same thing from the skin, it gets absorbed into the capillaries and small blood vessels and gets into the blood. And then once it's in the blood, as it gets filtered, the kidney gets exposed to these arsenical.
So can you talk a bit about the project through the center? What is the overall goal?
So our goal is to limit toxicity from arsenicals, particularly lewisite. So our goal is we've identified some targets that we get activated very quickly in the body when animal models at least are exposed to lewisite. So we are trying to interrupt those pathways. And one in particular reflects epigenetic markers called BRD4. So if we can block that, we can essentially reduce or eliminate significantly not only skin damage but also organ damage from exposure to lewisite. So our goal is to develop better molecules that can be given after exposure. So this is not prevention. We are trying to do post-exposure treatment. So if somebody in New York City is exposed to these chemicals, they can be first responders who can go in within a few hours and administer these antidotes. And so you can limit organ injury and really prevent morbidity, but more importantly, mortality from exposure to these nasty chemical agents.
And I guess timing is key there. You said
Very
a
important.
few hours.
Yes.
I mean, if it's given within a few minutes or 30 minutes, I mean, is it more
so
effective?
We're testing the appropriate time for administration after the exposure to these chemicals as well. That's one of our big goals of this grant, is to find the right dose, the route of administration, and also how quickly or how late can you give it and still have the benefit. Sometimes you may not be able to reach the site of the accident 6 hours or 4 hours. So would it be beneficial to give it? So first responders need to have that information. So one of our goals is to determine the time course, what is the best time to intervene. So that's part of our goal as well.
Can you talk a bit about other research that's going on in your lab right now?
So our lab is interested in a protein called heme oxygenase, and this enzyme was discovered, in the late 60s as an enzyme that breaks down heme from red blood cells. Okay. But in the last 20 plus years, it's been found that this enzyme is very protective when you have injury, and not only in the kidney, but in multiple organ systems. So my lab is focused now for 25 plus years on how this protein enzyme is regulated in the body. Can we manipulate this enzyme system for therapeutic purposes for the kidney and other organ systems? So we've done some drug discovery approaches to target this enzyme that we can upregulate. And arsenicals in particular upregulate this enzyme very profoundly. So our goal, one of the aims in the kidney project, is to see, can this enzyme, heme oxygenase, be used as a therapeutic target for arsenicals-induced acute kidney injury. So that's how it all ties in beautifully, and that's how I got roped into working with Dr. Attar and this collaborative group, and honored to be part of this center grant.
Well, and we're glad to have you on the team. So before we go, is there anything else that you would like to share with our listeners?
No, we are really excited. I think we've just finished 1 year of funding. So it's still early. We just had a review of our program by external reviewers. They were very positive about the progress we've already made in just a year. So we're really excited to be part of a team. We've got an outstanding collaborative team. The environment at UAB is spectacular to take such important projects forward. So we are excited to be part of it. And it's a great environment for training as well, for graduate students and postdocs and junior faculty to be part of a program like this and to learn and also further their careers, through this mechanism.
Absolutely. It will be exciting to see what progress is made over the next couple of years.
Great. Well, thank you very much.
Yes, thank you for being here. It was great learning more about the Kidney Project and the work to develop the countermeasures that you talked about that can mitigate arsenical-induced kidney damage. And thank you for listening. Please tune in next time for another episode from the UAB Research Center of Excellence in Arsenicals.